Hi everyone, I'm presenter Sungyoung Kim from KAIST Graduate School of AI. This is our paper, Coreset Sampling from OpenSet for Fine-Grained Self-Supervised Learning. Here's the quick preview of our work. The success of deep learning in general computer vision tasks has encouraged its widespread applications to specific domains of industry and research. However, for fine-grained tasks, certain expert knowledge is required for fine-grained annotation. Here, self-supervised learning could be a promising approach for fine-grained tasks without given labels. Besides, pre-trained model can be utilized on various downstream tasks, such as predicting different categories or bounding boxes, or even pixel-wise annotation. To build a versatile model, we can utilize the large-scale unlabeled dataset, referred to as an open set. The open set can be crawled from web or collected by pre-curated large datasets. In this work, we find out that performance highly depends on the distribution mismatch between target fine-grained dataset and the open sets. Thus, we propose a novel Coreset sampling algorithm to extract semantically similar samples from the open set. Since the open set may contain instances relevant to the fine-grained dataset, we found that addressing mismatch between two datasets is a critical issue. We can summarize our findings as two. First, SSL on the open set does not always outperform SSL on the target dataset. And second, if we co-train only with relevant class samples, it has shown the significant performance gains. Therefore, we propose a realistic problem setting open set self-supervised learning task. As shown in the following table, it is a novel setup compared to previous literature. And since we cannot know the class information, it is important how to sample the Coreset samples that share the same semantics with the target set. Now we would like to introduce our sampling method to find the Coreset. First, we need a retrieval model to measure the relevance score of open set samples. They are shortly pre-trained on the fine-grained dataset. And with the encoded representations, we measure the similarity as in equation 2. We used a simple cosine similarity between instance X from fine-grained dataset and instance U from OpenSet. Then we only sampled the OpenSet samples that are the nearest neighbors of the target samples. To reduce the computational overhead and make the algorithm scalable, we adopt k-means clustering for the target dataset X. So we replace X with the centroid set X hat. One remark is that if there is no constraint budget on S, a subset achieving the maximum value of f hat S is not unique. So we find a subset SSR that is a minimal set with the maximum value. Furthermore, since we want to sample sufficiently large subset, we introduce an iterative Coreset sampling by redefining equation 2 with the selection round T. So for 11 fine-grained datasets, as shown in our motivating experiments, OpenSet does not always improve the performance. When we set the sampling budget to 1% or 5%, SimCore has shown the performance gains depending on the distribution mismatch. However, because we do not have knowledge about the level of distribution mismatch in practice, we propose a stopping criterion where we stop at iteration T if the sampled subset is not as similar as the first subset is to the target set. SimCore is robust to various architectures and SSL methods. We have experimented with 4 curated open sets showing the significant performance gains. Regardless of the open sets, SimCore can sample relevant Coresets. We visualize selected samples of Places 365 Coreset for pet and birds, and iNaturalist Coreset for action and indoor. Captions are the actual labels in each open set. Interestingly, Interestingly, SimCore can find cat and dog images in the pictures of places annotations. Here we plotted histograms for their top 20 classes with the largest number of samples and visualized one example image per top 12 classes. Orange classes denote the similar classes to target data. Following the histograms, SimCore with larger K centroids could sample the similar classes samples. SimCore also outperforms baselines on various downstream tasks such as K-nearest neighbor classification, semi-supervised learning, object detection and pixel-wise segmentation, and multi-attribute classification. There are two frameworks from previous literature, OpenSet semi-supervised learning and Webley supervised learning, that utilized unlabeled or noisy-labeled OpenSets respectively. And from the extensive experiment, we found that first, when the SimCore pre-trained model is simply fine-tuned on each target, it outperforms OpenSet semi-supervised learning and Webley supervised learning methods. Second, SimCore can synergize with both frameworks, serving as an effective initialization. So if you're interested, please check our full paper and feel free to visit our poster assigned to Tuesday PM 3 to 6. Email us if you have any questions. Thank you for tuning in.